This puzzle is called Marry Camel to You by Panthera. It's going to be another Japanese sums puzzle, like I think we did yesterday or maybe the day before. It should be another Christmassy one, which will be nice. This one looks very daunting, and I'm not even sure I fully understand it. But, uh, based on the difficulties shown or voted for on the monthly puzzle prop channel of the CTC community Discord, there's a good chance this is on the easier side. 3 votes for just 2 out of 5, 2 votes for 3 out of 5. So hopefully on the easier side. These rules don't appear to be quite correct, so let me just read the rules listed here. So, a regular region Sudoku rules apply. So instead of, so these are 4 different 6x6 grids connected together. So here's one 6x6, and then, another 6x6. So instead of what would normally be like a bunch of 2x3 regions here, like in a normal boxed 6x6, we have a regular Sudoku. So this is one region. So this is going to be the digits 1 to 6 with no repeats. This will be a different region, and so on. And um, each puzzle is independent. So we'll have the digits 1 to 6 in this row, and then also again in this row. And same for columns. So like this will be 1 to 6. This will be 1 to 6. So that might make scanning a little bit difficult, but I don't think too terrible. It's just the digits 1 to 6. Okay, so Japanese sum rules apply, and we'll go over that. Colors used in this puzzle are red, white, and white has the green clues. Um, blue and pink. So there's 4 colors, and there are no unshaded cells. The red and white clues appear on the top and left side of the grid. So these clues all refer to white and red segments. While blue and pink appear on the right, and I think also on the bottom. Yeah, actually, the only strictly pink clue I see is this one right here. Okay. Um, where was I reading the rules? Okay, the clue. So yeah, Japanese. What does Japanese sums mean? If you have ever done a nonogram puzzle, it's like that except with Sudoku added on top. So if you know what a nonogram puzzle is and you enjoy those, I used to do them a lot before I got into Sudoku, and I enjoyed them a lot. So I do like Japanese sums. But let's go over exactly what this means. So the clues outside the grid indicate the sums of the contiguous runs found in that row or column that must be shaded the color of the clue. Green represents white. So this red 23 means that there's going to be a contiguous, which just means not breaking, just one set. So like this would be a contiguous run of cells, and these cells, let's say this was correct, will add up to 23, and it will be red. We're going to be drawing a picture here by the end, hopefully. If we if we do it correctly, it should be a Christmassy picture, but yeah, we'll see if that works out. So yeah, so we'll have some run in here just of a set of cells with no breaks in it that'll sum up to 23. If you look at, let's say, this one, the 4 and 3 will have some cells adding up to 4, and then sometime later, separated from the first, we'll have some cells adding up to 3, and those will be green. Okay. If a clue is black, then both colors must be present in that row or column. So what I believe this means is one of these will be a red sequence and one of these will be a green sequence, and we have to figure out which is which. There must be a different color run. Sorry, there must be a different color between runs of the same color. So like if we looked at this one, let's say, we say blue is here and here, and then we couldn't put, like we couldn't do it here. This would just be 2 segments. We couldn't say, oh, this is one segment and this is a different segment. We need to actually have them separated. And since typically in a Japanese sums, you would have some shaded, some unshaded. In this, every cell is going to be shaded. So we would need this to be, let's say, pink, or, well, I guess green isn't one of them, red or whatever. It could be in there, but not blue, because blue is what we're separating. If a row or column is unincluded, those colors do not appear in that row or column. So if you look down here, we are just not using pink and blue in these bottom 3 rows. I believe that's what that means. And sort of similarly, I believe this 5, the blue 5, means that pink is not going to be down here either. But pink will be in, I guess, these 3 and in those. Yeah, so hopefully this is on the easier side. I'm not quite sure. We'll see how this turns out. I'll put a link to the puzzles down in the description if you want to give it a try. Let's get going. So the first thing I see is this 42, red 42 here. So the first thing that's important to note is in a 6x6 puzzle, we have the digits 1 to 6. If you add up those digits, we get 21. 1 plus 2 plus 3 plus 4 plus 5 plus 6, 21. So a single row or column in a 6x6 puzzle adds up to 21. So this is going to be 21. And then we have 2 rows. We have 2 different 6x6 puzzles here, of course, separated by this line down the middle. So this will be 21 and this will be 21. 21 plus 21 is 42. So the whole bottom row is just going to be red. And we can't, I guess one thing that's important to know, we can't have multiple colors in the same cell. That makes sense? So we will hopefully be able to reduce some things that way. So like this 33 now can't take this cell. So we actually only have this many cells, which is going to limit where we can put these blues, which hopefully in turn limits other stuff, and so on. And in fact, let's just look here. 33, I don't know why I said 32. 33 means that there's 9 left over, so we could have as many as 3 cells unshaded, but we need at least 2 cells unshaded, and this red counts as unshaded. So we need at least 2 cells unshaded. So how many is that? So if we left 2 unshaded on either side, we could have 3 unshaded on either side, isn't that right? Yeah, if we had 3 cells adding up to 9, we could have these 3 cells adding up to 9, and then we would have a string of 33 blues like this. Or we could have, what am I trying to say? Or we could have these 3 adding, no, we are guaranteed to have this one unshaded. So I think it would be like this. We could have 2 extra cells unshaded plus this cell. Or by unshaded, I mean not blue. We can have we can have at most 3 unshaded cells or non-blue cells. Yeah, we can have, at most we can have 3 non-blue cells. And actually, we can even just take that a step farther and make this easier. Look at the top clue. We need 9, and that's how much the red adds up to. So we're going to have 2 or 3 cells at the bottom, because we already know this is red, so this 9 needs to connect to this red. We're going to have 2 or 3 cells here be red and add up to 9. Then we're going to have, what is that, 6, 10, or 9? Is that right? 1, 2, 3, 1, 2, 3, 1, 2, 3. Yeah, 9 or 10 cells adding up to 33 over here. But we don't know which one that is. I don't know if it'll be helpful to mark that, because we know it's either blue or red, but I don't know if it's helpful to mark it like that. Okay, what about this row? Yeah, and I think taking both sides into account immediately is the way to go. So we have, now I'm a little confused. Oh no, sorry, I thought this was a 5, 2. So we have 5, 3, which adds to 8, plus 34 adds to, what does that add up to? Oh, and I already know blue isn't in this row, because there's no blue clues over here. So this just must be red. Okay, sorry. I'm getting a little used to this puzzle. Some, no growing pains, I guess, figuring all this out. So let's look at this 34 clue. We have a string of 5 blue, which could be 1 or 2 cells. And then we have 3 on the other side, which is 1 or 2 cells. Then everything in the middle has to be green. And we know that because if we add these up, we get 8 plus 34 is 42. So we have a segment in the middle that's green, and then this one is at least blue, but then these cells are green or blue. And I guess we actually know there's no green in this column. Whoops, in column 2 we know that there's no green because it would be marked up here. So this can't be green. So this must be blue. This one could be green because there are greens up here. Okay. Okay, so this is warping my mind a little bit. I'm still not sure if I have a good handle on this. So we know that the 13, the reds are going to add up to 13, and they must connect off of here. There's only one segment, so we're going to have at least this many. We could have it up to this many. And actually, we will have up to this many. If we look at this row, we only have one segment of blue. If we put blue here, if we put blue here, that means this whole row must be one segment of blue, which is not going to add up to 5. So the blue 5 segment is going to be over here and separate from this side. So this must be 4 reds, and then the rest is just going to be blue. We couldn't have 5 reds because if we add up the minimum digits, 1, 2, 3, 4, 5, we get 15, which would be obviously greater than 13. And in fact, I think the same thing is going to happen on this side. So we need, or wait, is it exactly the same, or just, we know we need at least 3 cells. 4 plus 5 plus 6 adds up to 15. So it could be 4 plus 5 plus 6 here, adding up to 15. And then the rest has to be blue, but it could be 4 cells. So this cell could be blue, or this cell could be blue or red, I think, actually. Because we could have a segment of 2 blues adding up to each other. Okay. So we know, okay, so here's something. This row, we're going to have a big segment of red in the middle. We're going to have a blue on the left and a blue on the right. Blue on the right must be at least 2 cells because we can't put a 7 in the grid. It must be at minimum 6 and then a 1. It could be 3 cells though if it was 1, 2, 4. And 9 can also be 3 cells. But everything in the middle is going to be red. We don't need to mark the whites. I think I am going to start marking these cells as one or the other, so we at least have some indication what that cell might be. Okay. Where's an uncomplicated cell? Or uncomplicated column, I guess I should say. Maybe this one is as uncomplicated as it gets. Or maybe we just look down here because we don't even have to worry about blue and pink. We know there's going to be a red or a green segment, and then we're going to have the opposite color, and then we're going to have the first color again. Well, we know what the first and last segments must be. They must be red because we've already put those in. So the 15 is red, which must be at least 3 cells. 17 must be at least 4 cells. This could be up to 5 though, and this could be up to 5 as well. And these middle digits must all be green. But we can only have 4. Actually, no, we could have more than 4 digits adding up to 10. That's going to wrinkle my brain a little bit. This could be 1, 2, 3 on this side, and then 1 and 3 on this side, and have 5 digits adding up to 10. Have I messed up the logic? I think this is the first time I've had logic that crosses the line between the 6x6s, but I do need to keep that in mind. Yeah, everything else I've been doing is right along the edges, so I don't think it's mattered, but definitely theoretically, it could cause problems. We can do the same thing on the third to last row. It must be 4 14, which must be red. So that must be at least 3, and up to 4. Then we need a string of greens. And then we need up to 6, or a total of 6 on the right, which could be 1, 2, 3, or it could just be the number 6, actually. Okay, are we getting anywhere with this? Okay. Yeah, I'm not sure if we're making good progress on this or not. So this 5 is going to be over here on the left. Then we're going to need some color, red or green, then the opposite color, and then the first color again. But the last color is red, which means the first color is also red. So we're going to have a 5, which could be 1 or 2, then 8, which could be up to 3. 5? What's 5? No, it couldn't be 3. I think because 5 plus 8 is 13, so we can't have more than 4 cells allotted to the 5 and 8. But it could be as few as 3 cells. So then we need a green that adds up to 26, which is going to be basically this whole thing. And then we need 1 or 2 cells at the end to add up to the red 3. So this is a 1, 2, or a 3. Is there anything we can do? These must be, since we have 4 of these, this must be fairly small digits. Although 1 to 6, they're all fairly small. But we know this blue segment is 3, adds to 3. We know this red segment adds to 3. So I think they must be different, because if we put a 3 here, then this one couldn't be a 3 as well. But if we made this 1, 2, then this couldn't be a 1, 2 as well, because these are all in the same, region here, this region. So this must, one of them, yeah, we're gonna have one of each here. So these, yeah, 1, 2, and one of them must be a 3. I don't know how helpful that is. I immediately see that this segment must be a 3 as well, but it's in a different 6x6, so we don't know that this is a 3. Maybe we go for a segment with a lot of options, because we have 1s here. And in fact, this is confusing, because we actually have these 2 segments as well. That's, I don't know what I was trying to say. That we sprinkle in somewhere. These 1s must, no, they don't have to be different colors. My first thought was these 1s have to be different colors, but that's not true. This 1 could be in this 6x6, and this 1 could be in this 6x6. And that would be perfectly allowed. We do know that this is a blue segment, obviously, because it's literally the color blue, and is going to be the 5. So this is 1, 4, 2, 3. Yeah, I don't know how helpful that is, but we can write that in. Sorry if you can hear my chair. Maybe the 6. Could this be a 1, 2, 3? If this is 3 and this is 1, 2, could this not be a 1, 2 as well? And then have this be 1, 2, 3 triple. I feel like that works. Okay, let's just keep looking at these. So we have, this is going to be a 16. This must be the 16 red. The last segment is going to be 16 red. So we need a 16 blue and we need a 10 green. Well, the green is next, so we must have at least At least 2 for that. And this can't be red, actually, anymore. This must be blue. Because red would make a third red or green segment in this column, which isn't allowed. So this must be blue, which means this is 3 digits to add to 9, which is perfectly fine. Green could be up to this many. 16, so blue is from the top, and it could be as many as 5 cells. And green could definitely be 4 cells because it crosses the line, so there's actually a lot of options there. This must be, wait, does this have to be a 2 then? I think it does. So we have this segment here, which must be blue, and since we changed the color, it must be blue, and that's the full region, so this adds to 8. Now we don't really know what that is. There's a lot of options, or a couple options at least. But this must be a green segment. Obviously, we've already colored it green. So this, I think, just must be a 2, which is going to be our first digit here, like 26 minutes into the solve. But we finish off that clue. So this could be a red 1, or it could be a blue or pink 11. That is less helpful. Okay, what about, oh no. Actually, I think this must be a 1. If we look here, the last segment is going to add to 1, so this just must be a 1. And then we know it's, yeah, and it's obviously it's red, so we look up here. Okay, so what about, this 16 must refer to this green 16. Could it be a 5th cell? No, because that would be 17 for the full 6x6 box, but the full 6x6 box adds to 21. So this is the full, this is the full 16 segment, so we have 17, so this must be a 4. But this could be part of the red 11, or it could be part of a pink or blue 13. Yeah, we just know it's number 4. We know it's a number 4 and it's not green, I guess. So this is red, pink, or blue. I don't even know if it's helpful to mark that at that point. This red is part of the 11 segment, but I think we could bring it down like that. Okay, what about this one? I think this is where we need to look now that we've filled in a lot of stuff down here. The last segment must be red or green. We already know it's red, so it must be this 2. This must be a 2. 18. Again, it can't go up here because that would be 20 for the full thing. This must be a 1 and can't be green. But it could be this one. Or it could be part of this. So all we know is that it's not. All we know is that it's not green again, which isn't super helpful. It's a little helpful, but not super helpful. Let's look at this one. So the last segment is 4, which could be, this 1 is not affecting it. So it could be a 1, 3, or it could just be the number 4. I don't think that's a problem. What about this segment right here? 9, 15, and 5. So this is definitely a 5, but it could be a 2, 3. This 1 does affect that because it's in the same region. But it's a 2, 3, or 5. This 2 does not look over that far because of this line here, kind of in the middle of where I just selected. These add up to 9. These add up to... These, possibly including that, add up to 15. Oh, no, never mind. I saw this 8 and thought this must add up to 8. But no, it's this 5 is here. So this could be a 5, or it could be somewhat restricted. Darn it. Okay. So we've done this one. We know this adds to 16. Okay, well we can do the same kind of trick here, I think. So we have a 5 segment, and then we have a 15 segment. That adds to 20, so it can't take this cell. We need one more here. Yeah, we need one more here. Could this be, this couldn't be red this time actually, because the 9 can't reach down that far. Wait, no, it could reach down that far because we go across the border. It could be like a 1, 2, 5. Sorry, one second, I need to send a message. Sorry about that. Hopefully I cut that out. I just had to send a message real quick. 11. No, we need a red. All the different colors is definitely tripping me up here. So this is a 5. Then this is either a 4 or it's 2, a length 2. No, it couldn't be a length 2. It couldn't be length 2. So if, let's just see what happens if we make this length 2. Then this 4 will be a 1, 3. Then this 5 can't have a 1 or a 3 in it, which means it would be at minimum 2 and 4, which adds to 6. Doesn't work. So this is just a, whoops, this is, come on. This is just a 4. Which means this must be a 2, 3. Which means that this green 3 is somewhere over here because we can't do a green 3 on this side anymore. Which means that this must be a blue or a pink cell that adds to 5, and it would have to be the number 5. Right? We've done this 5. This 5, we can't do 1, 4. We can't do 2, 3. We couldn't do this 3 segment. We just talked about that because it couldn't be 2, 1, or just a 3. So it must be this, and it must be a blue or a pink that's just a 5. Then we have a 1 that must be a blue or a pink. Oh my gosh, this is getting a little, this coloring is getting a little bit wonky. This 1 is the opposite of whatever this color is. And then we have a 17 that must be at least, wait, this will be a 6. So then we need 11, which has to be, I guess, at least 2. So these 3 are in the same group. But at that point, we can do the 3 again. And then a 1, 2, 4. There's so many segments here. Let me see. So this, we have the 5 here. How many segments is this? 1, 2, 3, 4, 5, 6, 7, 8, 9 segments. We have 12 cells. 17 must be at least 3. And the 5 is 2. So that's, wait, let me count this again. 1, 2, 3, 4, 5, 6, 7, 8, 9. We need 2 extra cells for the 17, so that's 11. 1 extra cell for the 5, which we've already used, is the 12. So everything is minimum number of cells. So we don't know what these are, but we do know the order. This is a, oh, but we don't know where the 3 comes in. So we have a 1, 2, 4, and then we have a 3 somewhere. I guess no, this has to be the 4. But the 3 from this side could really be anywhere. So this is a 5, 6, which means this is just a 6, which means that's a 5. But that 5 could be a green 5, or it could be part of this 21 and have it be pink. And this is 5, 6, and this is the 17 section. Yeah, this could be, now I'm getting, Yeah, we can't alternate colors because if this is the green 3, this could... Oops, sorry. Phone alarm going off. This could be 2-1, and this could be blue, or it could be pink. Either one would be just fine. So we don't know that what colors, besides the 3, which is somewhere, we don't know what the colors are, except that they alternate. We know this one is not blue, and it's not red, so this is green or pink. And actually, there are no pinks in this column, because of this clue down here, it would have a pink section. So this just must be green, which means it is the green 5. Okay, that's actually very nice. Where could that be down here? I think it must be part of the 18, right? Now this cell, or this column is getting constricted. We need a 4 segment, a 1 segment, an 18 segment, which must be here. So before this must be part of the 18 segment, right? Yeah, now this is blowing my mind. Um, this must be part of the 18 because it can't be part of the 11. The 11 is going to be part of the red. So this must be part of 18, which means it must be at least down to here. This couldn't be blue. If this was blue, we would need to make 18 in that many cells. So this has to be blue. Sorry, can't be blue, I just said. Must be green, which just makes this a 3. Makes this a 1, 2. If I remember correctly. Okay. Which means this is no longer part of the... This is the 18. So this needs to be... So this is either 7 or 8. It needs to add to 18. So this needs to add to 10 or 11, which is going to be like this. This 4 does not look over that far because it is in the other 6 by 6. Okay. Which means this is not green because we need one contiguous segment of for the 11. Which makes this 1, 2, 3, 5. That's just how you make 11 in 4 cells. That's the only way to make 11 in 4 cells. This 2 does look over, but not the 1. And that 5 looks up and means this is not 5, which means it adds to 10, which means this needs to add to 8, which gives us the green 3, which I guess we could have figured out because we said it was green anyway. Yeah, I guess we figured that out in the harder way, but it was the way we were thinking about. So this could be blue or pink, and they alternate all the way along here, except for this 17 segment. We don't know which one. If we knew any one cell, we could color the whole row. But we don't know any of the cells, at least at the moment. Oh, wait. There's no blue in this column. That means this must be pink. Because the clue is not black, we know that this cell must be pink because it must be blue or pink. And it can't be blue, so it must be pink. Yeah, so the 17 is pink, which makes the ones next to a blue, which makes the ones next to that pink. There we go. Oh yeah, it's like, what the heck is this gonna be? Just realized it's Santa Claus, but we're giving Santa a green beard. So I'm gonna change the green to white at the end. But yeah, I was like, what the heck could this even be turning into? But I think this is Santa with a big old beard. That he probably needs to wash because it's all green right now. Okay, so we have this is the 18. Oh, this is blue. So we're going to have a segment that adds to 6, but it could just be the number 6, or it could be a 2, 4. No. So if we come from the top, we're going to have the number 4. Because we can't do 3, 1. We've already used the 3. Actually, we have a 1 segment as well. So we have a 4 up here first. I don't know what color that is, but it's red or green. Then we have... Oh, wait, now I'm confusing myself. Oh, we haven't done the 2 segment yet. For some reason, I was thinking we had... Okay, I was like, these numbers aren't working. I'm not using one of the numbers. This is not part of the 6. This is part of the 2. This must just be the number 2. Then we have a red or a green segment that's the number 1, because we need a space between the 2 and the 6. Then we have a blue that is just the 6. But that breaks the puzzle. Oh, it breaks the puzzle because I made a bad assumption here. When I said that this was the 6, that led me down the wrong path. Let's go back to here. This is the 2. Now we have a 4, a 1, and a 6 up here. If we tried to make this the blue 6, what happens? Well, now this segment has to add to 2, but we have a blue 6 in there. 6 is already greater than 2, obviously, so that can't be that. So this must be a 1 or a 4, and it's red or green. We don't know which. This can't be the 6 because I would put the 2 blues right next to each other. So this is the 1, this is the 4, this is the 6. This is blue. This must be red because there's no green in the row. So this is red. This has to be the opposite. This is green. We need that 2 segment here. This is going to be 23, which must lead all the way over to here. This is 19 because we know the full thing is 21. Minus 2 is 19. So we need total of 4 on this side. So it could reach to there. And then the rest is blue. Ooh, that was okay. I think I am getting the hang of this now that I've been working on it for 40 minutes. Okay, so this segment is 13 plus 3. 13 plus 3 is 16. We need a 5 to finish off the column. And then we need a 1, 2 to finish off the region here. This 2 does not affect that. So this is a 6 and a 4. Okay, I think that's fine. Okay. Yeah, there's just so many places to look for clues. It is a little daunting. Oh no, this could be 1, 2, 4. If this is a 1, this could be a 4 still. Or this could be a 5 to make 7. Either one works. Yeah, either one works. Okay, where are we gonna look now? Oh, this must be a 1. This needs to be a segment that adds to 7 in blue. This can't be any more, so this must be red. We can at most... Actually, we can just figure out how many... 1 second, sorry. Throat's getting a little scratchy. So we have a segment of 7 and a segment of 11. That's a total of 18, so we can't fill the full row in the 6x6. That must be a 3 then. And that must be part of the 24. We need 21 and then plus 3. Yeah, that math works out. So that's the full 24 up there. This is going to add to 11, which must be 2, 4, 5, because that's all that's left in the row. This is a 1 and a 6 to finish off the region, and a 5 and a 3 to finish off this row. Then for this, we need a 4 and a 6 to finish off this region right here. I was hoping that eventually one of these digits would come into play. I guess this can't be a 2, but it's not helping that much. This must be a 3 and a 5. These 3 and 5s do not affect that. This is a 3, 5, 2. With the 2's over here, this can't be a 3. Oh, this can't be a 5 because it's in the same region as this 5, 6. So this is just a 2. Whoops. What's left here is 1, 3, and 4. This 3 is looking down, so we put the 3 there. Now these 1s are looking up. This is a 6, this is a 1. This is a 5, this is a 6. What's left here is a 1, 4, and a 2. This 2 literally right next to it is going to figure out at least a little bit of it. This can't be a 6, so we're gonna have a 6 in there. Is that helpful? Oh, this 3 is looking up. That can't be a 3. Which is gonna give us a couple more digits. This can't be a 5. This is a 2 or a 4, and it can't be a 2. So this is a 4, which is gonna give us hopefully a lot of more digits, but maybe not. This is a 3, 6, and we just kind of. We know this is We know this is the full blue segment, so this must be red. Do we know anything about up here? We need. Oh my gosh, there's just so many numbers. I like just doing the Sudoku. There are just so many numbers. Um, so we have a 3 segment, which is the blue. Now we need it. The next segment is going to be a red, obviously, because we've colored it red. Wait, now I'm getting confused. This clue is for this. 1, 2, 3, 4, 5, 6. Yeah, this clue is for this. This clue is the 9 here. So we need a segment of 9, which means this must be red. And this is the full segment. Now we need either a 1 that's red or green, which is not this. So we need a segment of 4, sorry, a segment of 9, including a 4. So this must be pink. This is a pink 9. This can't be pink then, because the pink is done. Actually, blue and pink are both done. So this must be red. And now we have an 18 segment, which is just basically whatever we have left. And then we have the 2 segment at the end. Yes. Okay, so we're done with this column, actually. I guess technically we were done with the couple column before then, but this one is the first one I really feel like we're done with, although that's not true, obviously. This can't be a 3. We have a 3 in here somewhere, so this can't be a 3. And actually, this can't be a 3 either. So this just must be a 4. So we're looking at this 4 segment here, which is red. We can't do 1, 3. Whoops, we can't do 1, 3 because we've already used the 3 in the cage, because we need a 3 in this column over here. So this can't be 1, 3. This just must be a 4. And then we have a 15 segment, which can't be everything because 15 plus 4 is 19. Can't be the full column. We need a 2 here. We don't know what color that is, although do we know anything? It can't be green, so it's red, blue, or pink. And actually must be part of this 11 here, because we can make 9 here, but we can't go up any higher. So this must be a pink segment, and then we just kind of have the junk left over in the column segment right here. That's the proper terminology, the junk left over. So that's not a 3. This is not a 3. Oh, all of these aren't 4s, so that's a 4. This must be the 1. These aren't 1s then. We have a 3 in here, which isn't helpful, unfortunately. Oh, this 4 is looking over. Makes this a 6, makes this a 4. That is going to give us a bit. What's left here is 3 and 6, and then 1 and 2. These 1s and 2s do not look down here, so that's fine. This is 4 and 5, which means this is not a 5. Okay, where do we even look now? I like when I know what I'm doing, because I can just, once I start zeroing in on a place, I feel like I'm understanding the thing, but once I'm like, okay, I need a new place to look, I get a bit overwhelmed. But I think this must be red, because we need a segment that's 12. This is 3, so we need more. Make this red, and that actually adds up to 12. So this is the 12 segment there. Then we need to have the 11. Then we have the 15 segment, which is 9 plus 1 is 10 plus 5, and then we have the 4. Okay. Well, let's just go. 18 is such a big number. Okay, so what about this column here? We need a 1 segment that's blue. Since the first segment here, we already colored it blue, so we know it's blue. The first segment is a 1. Now we need either a no, it must be red. We've already colored it red. So it must be an 11 segment, which needs to be at least 3. Actually, it can't be 4 because we've already used the 1 in the column, so we only get 3 here. So this is 11 and 3. That's 12 total. 12 21 minus 12 is 9. So we have 9 here. And then we need a 13. So this 4 is, whoops, this 4 is pink. Part of this segment. Okay, and then we have the trash left over in the column segment down here, the 16. Okay, we know what these are. These are 2, 4, and 5. This 4 is not looking up there, and none of these digits are looking over there. That's really tempting to make that a 4, but it's not true. Or, not necessarily true, I guess I should say. Okay. Oh, here we go. So this segment, this column, we know the first segment is blue, so we look down here. It's a 9. We can't do 9 in one cell, so this must be blue here. And actually, we can probably do this math. What is this? This is 19 because we have 2 left over. So this has to be a 4. Okay, so it's not a 4 there. Okay, that's good. Now, do I want to bother filling this in? Not really. Okay. So this column, whoops, this column we could do 2 or 3 to make 9. Maybe we can focus on this row, figure out the coloring here, because we do know a bit here. So we have the 3 here. We have the 1 that's green. So this is either a blue 6 or a pink 6. No, sorry, it has to be blue because this is blue. So this is either a blue 6 or red and be part of this 18. If this was red, this would all be red, which would be 10, 17, at least 19. So this is not red. This must be blue then, which means it must be part of the 6. If we made it a 4, we couldn't make it into a 6 in any way. So this is just like this. Now we can't do another blue for it. We can't make this blue again because we just had a blue segment. So it has to be part of red. That's 11. So we need 7 on this side, which must be another 2, 5, 2 or 5. Oh wait, no, it could be 1, 2, 4, couldn't it? It could be 2, 1, 4, and then have 14 with, what is that, like 3, 5, 6? Yeah, I think that works. Okay, so we know this is red, but this cell here could be red or blue. Okay. Did I say earlier that this had to be 9 because of this is 9? Or because of this? This does have to be 9, but because of this 9, not because of this 9. Hopefully I didn't do that. I feel like I said because of this 9, but it's because of this 9. Oh, that's cool. Okay. What segment is this blue 1 part of? It's not part of the 9 that's up here. Could it be this 1? One of the standalone ones? And no, I don't think it can be. Wait, then how do we have 2 different segments that add up to 1? Now I'm confused. Have I screwed this up? Am I looking in the wrong column here? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That's 29, 30, 31, 32. No. Okay. Okay, so this is 9 blue. This can't be a 2, so this must be part of 9. Oh, okay, I see how it is. Okay. I was wrong. I was thinking that I was forcing this to be a 2 1s adding up to 2, but that's not true. That's not true. So this is going to be the 9 blue here. Whoop, this is this 9 here. This is this 9 here. Now, if we make this, and I guess we can add that up. So that's 18. So we need 3 here, which puts a 2 here. Actually, no. I skipped a step there, sorry. This 9 is this 9 right here. This 9, which could go up to here, is this 9. If we tried to make it 5 cells long, that would be 18. In 5 cells, this last cell would have to be a 3. We know that's not the case. We know the leftover in the column is going to be 3 because 21 minus 9 is 3. So it must only be 2 cells, and this must be a 2 to fill up the leftovers. Now, this must be 3, 6. I guess we could have said that because that's what's left in the region. This must be 4, 5. And again, this stuff over here doesn't look over, so it is a little confusing, but that's... I don't think we can reduce that much, if at all. So now what is this 2 part of? And this 2 is this 2 here, which is separate from the 1. This 1 must be this third one down here. So this 2 needs to not be part of this 1, so it needs to be a different color. And then this 1 is this other 1, because it can't be part of the green, so it must be a pink 1. And now we have 15, which could be 4 or 5 cells. Sorry, 3 or 4 cells. And then we have a 5 that is the red, the final red. Okay. Okay. What was I? Oh yeah. So I did notice here. So this region, where do we put 2 in this region? This 2 rules out there. So we have a 2 in one of those 2 cells, which makes this a 5, makes this a 2, and does reduce things a little bit. And actually, this is a 2-3 pair because this 3 also looks over. So this is a 1-6. This is a 1-6. This is a 4-5. This is a 1-6 for this region. Where do we put 1 in this region? We can't go here because we have a 1-6 looking up, and we have a 1 here looking over. So this is, whoops, so this is a 1, which makes a few things resolved. Where do we put 6 in this region? We can't put it over here because of the 6 is looking up, so this resolves a bit. Okay. Okay. So this is 1, 3, 4. This can't be a 4. This can't be a 1. This is 2, 5. That's a 3 then. Which makes that 2, 3. This is a 4, 5. This is a 3, 4. Actually, wait. This 3 looks up, makes this a 4. This is a 4 or 5. Which has me a little worried, but that's okay. I can be a little worried. Figure out how to resolve that later. So we need, this is a blue segment, so it has to add up to 9. The first segment is going to be 9, so this can't be blue as well. This is supposed to be green. First green segment is a 1. Okay, so now we're done with that green segment. And actually we're done with green totally because these are the 2 segments. So now we have a 21. This must be part of that. That's 11, 18, 21, then a 5, and then the 6 right there. Okay. Okay, let's look at this column maybe. So we have a blue. Oh, this 1 is going to resolve some stuff. This is a 3, this is a 1. So this 3 is going to make that, which resolves that, which resolves that. Okay, so this is a 12. Oh, I've messed something up. I have messed something up. Oh darn it, I just have 3 4s in column 2 of of the first 4x4. 1 second, I need to back up. Okay, so this is a 4. Then I wrote 4, 5, but that's not true. This 4 makes this 5, 4, 5. Okay. My spidey senses were right about the fact that I had 4 5s looking at each other there. Okay, 4, 6. This 4 looks up and resolves that, which is going to resolve everything. This 5 also helps. Okay, so let's look at this row. We need 14, which is going to be here, so this must be blue. Then we have 10, 18 in red, yes. Then we have a 6, then we have a 1. Okay. Let's look at this column. We need 16, which is 10, 16, so this is not blue, which is the same thing we got earlier, because 4, 5 is 9. This is pink. These are pink. Okay. What about this column? We need a 7, we have a 7. We need a 3, we have a 3. We have 11, which must be part of the 17, because it's, yeah, it must be, because it's pink, it must be down here. Which means it must be like this. It must be a 6. Now we have a 3, a green 3. So this is a 1, 2, or a 3. And it could be there, but these can't be greens. Now we have 12 down here, or up to 4 cells. Okay, so that gave us a little bit. This is 3 and 5. This is 1 and 4. So this can't be a 1 any longer. Helps a little bit. Okay. So this red down here adds up to 15. Was that a problem? If it goes here, then these two would need to add up to 7? No, 6, which could be 1, 5. Yeah, that works just fine. Okay, let's look at this column because we can resolve a little bit here maybe. Oh no, that's literally where we just were looking. Let's look here then. 9. No, oh no, we already examined that. We literally, yeah, we did that very recently. Oh, this 4 makes this a, whoops, makes this a 6 and this a 4. This can't be a 1. Okay. So let's look at this row here because we've not colored some stuff in here. So we have an 8, so that's the blue. We have a 2, which is the green. Then we have an 11, which must be the pink, yeah. Then we have a 1, which is red. Then we have a pink, which is another 11, which must be all of these. And then this is the 4 there, and then this is the 5 here. Okay. Yeah, let's look at this column. So we have a 1, blue 1, and after that we need a pink, which must be a 3, which is going to go like that. Unfortunately, that doesn't look up and resolve that. But we can resolve it right... Oh, we can resolve it in a second. Yeah, let's do that actually right now. Okay, so this column... yeah, it's right here, so we need 9, so this must be 4, 5. Oh, you know, in fact, there's a 6 right here. I was thinking this was a deadly pattern, but this is not a deadly pattern. We can just resolve it. That's a little bit easier than I anticipated. Okay, I like that the 1s are eyes. That's funny that they both turned out that way. Okay, down here we have, so we have a 9, then we have a 6, then we have a 3, then we have a 9. So after the 3 up here we have a 5. This has to be 5, so this can't be green. Oh, this must be 4, 1, which makes this a 10. It must be 2, 3, 5. This can't be a 2. Okay. Then what's here is a 6, 1, and 4. This is just a 1, because we have a 4, 6 in the row. This can't be a 1, then this must be a 2. And that's going to resolve, hopefully, a lot. This must be the 2. It's the last spot left in the region. Oh, this 4 is going to make that resolved a little bit, maybe. Maybe not. Maybe not as much as I thought. Okay. Where to look now? Let's look at this. Yeah, that's going to give us a digit. So 17, we need this last segment to add up to 17. We have 10 plus 2 is 12. This needs to be a 5. Okay, we've figured that all out. So now we have 4 here, so this could add up, this has to add up to 6, which could just be the number 6. Or could be 2 digits adding up to 6. Unfortunately but they both seem to work. Okay, this has to add up to 5, but this, I think this could still be 2 digits here. Okay, where do I need to look? Maybe I just need to start filling in some digits, or like filling in options and seeing how that breaks some stuff. So we've already done all the blues and pinks, so this is just up here. This is a 15 and then a 5. Um, yeah, so that is basically, yeah, that doesn't help actually. And this is a 6 or 2 digits that add up to 6. Okay, well, okay, maybe we need to do both of those together. Let's assume this is red, which means these two together add up to 5, which means this is 2, 3. Oh, so that just is a 6, never mind. I was thinking that there was, sorry, I was thinking that if this was a 2-segment long, then it would force this to also be a 2-segment long, but with a different digit there. But that's not the case. One of them is a 2-segment long thing here, or this one. So this is either a 4-2, like this, with a 5 here, or this is 2-3 with a 6 here. I think those are the options at least. I'm actually not 100% sure on that, so I don't want to fill that in. But I think those are the options. Okay. So we need 15. If this was red, then this would all be 15. Yeah, and this would be the 6, yeah. That's how that would work. Okay, so we need this green segment to add up to 26. We have 17, so we need 9 more. We could do that in 2, or we could do that in 3. How about right here? This is where we need to look. This is where we need to look. Okay, so we have 7, then we have the 3, then we have a 17, and then we have a 3. A green 3 up here. Oh no, that could be 1, 2. I saw the 3 and got excited. So this could be a 1, or it could be anything. It could be a green 1, or it's part of red. This corner is tricky. Okay, what am I missing? I think there's something that I'm just missing that's easier. So this is 9 and 3, which means this is going to add up to 12. There are 3 options for 9 and 3. It could be 1, 2, 6, which I think works. 1, 3, 5 does not work because we have a 3 or 5 here. So it's 1, 2, 6 or 2, 3, 4. So there's always a 2 down here. 1, 2, 6 or 2, 3, 4. So there's always a 5 in one of these 2 cells. So if this was a 5 that's 2 digits long, this would be 1, 4, 2, 3, or just the number 5. This couldn't be 2, so this couldn't be 3. But I think it could be 1, 4 actually just fine. Darn it. This last bit is tricky, or maybe I'm just dumb because this adds up to 10, and this must be a 3 then. Because that's how you make 10, and so this is just a 2, so this is the green 1 that we talked about. So what's left here is 3, 4, 5. 4, 5, 6, like that. Which means we need 2 digits to add up to 8. In red, so this can't be a 4, this is a 2 or a 3. This is just a 5. This is just the blue 5. So this is a 3, this is a 5. So this must be 1, 2, 6. This is a 4, this is a 1. This must be a 6 because of that. Means that makes that a 4 and that a 5 to finish off the box. This can't be a 5 or that. This is 1, 4, 5. This can't be a 5. The 6 is, whoops, this must be a 6. It's the last spot in the region here, so this can't be a 6. What's left is 2, 3, 4 with a 4 guaranteed, and actually it can't have a 2 because we already put the 2 in the box, so this is the 2. Okay, what about this cell? This cell must be a 3. This is a 6, 5. This 5 is going to resolve that. This is a 2 or a 3 just to finish off this column. This is a 2 or a 6. Oh, this 6 is going to resolve that, which is then going to resolve a lot of stuff. Okay. So maybe it's based on coloring, or maybe I've just done something wrong. I'm not sure. But let's just make sure I get this coloring right. This is 2. This needs to be 15, so this is 2 plus 4. This is 10. Yeah, this is just the 6. Yeah, this is red like this. Let's change green to white. Can we find a better pink? Maybe this. Let's just go with this pink. And hit check mark. Where's the check mark? Did I miss some rules? That this is maybe the checker just can't do this because there's so many digits. But I think this is right. This looks like Santa with a big white beard. Oh, even didn't even realize what that was. That's the little like pom pom on the back or the tip of his hat. Yeah, that was a great puzzle and obviously very festive. Thank you very much for suggesting that, Panthera. I don't know how. Probably at least 3. I think 3 out of 5 difficulty. Um, but that was fun. I think a lot of it was just how many clues there were and kind of wrapping my head around how the puzzle could work. I don't think necessarily moment to moment there was a lot of super difficult stuff, but maybe there was and I just don't remember. But I think a lot of it was just there was a lot of information and piecing that information together correctly was tough as opposed to some, I don't know, great stroke of genius that I had. Anyway, I really enjoyed that. Thank you for that puzzle, Panthera, again, and thank you all for watching.